Hey guys, good afternoon. Well, today we're going to be talking and learning about Ohm's law and the power formula. So get ready, bring out your pen or your pencil, your calculator, and a piece of paper, and let's go over these two formulas and see how they will help you become a better apprentice. Let's do it. Okay, the first formula we're going to consider is the power or pi circle formula. And basically this is the way you want to remember, like a piece of pie. P is for power, I is for current, E is for voltage. So if you want to find the current or the amperage, you take the power, which will be represented by watts, and you divide it by the voltage. If you want to find the power, you multiply the current or the amps times the voltage. And if you want to find the voltage, you take the power or the watts and you divide it by the amperage. Why did they use these letters? Well, power, we know what power, or P for power, right? But if you can see here, P represents power. The letter I represents the intensity of the current, hence the letter I. And the letter E represents voltage. Why the letter E? Well, a good way to remember it is that originally they would use the term electromotive force. And since the letter E is the first letter of that term, they kept the letter E to represent voltage. kW equals 1,000 watts. The K will always equal 1,000. 1 kVA equals 1,000 volt amps, and 1 horsepower equals 746 watts. Okay, let's try the first example. Determine the available power in VA for a 100 ampere 240 volt single phase circuit. Now remember, the power may be expressed as true power such as watts, kilowatts, kW, horsepower. Power may also be expressed in terms as apparent power such as volt amps, VA. That's what we're looking for, VA, kilovolt amps, or kVA. Okay, so what we want to do is that we want to find the power. Find the power. So we know the amps, which is 100. We know the voltage, which is 240. 240. So 100, the amps, times 240 equals 24,000 VA. Where's 24,000 VA? Right there. Answer B, 24,000 VA. Let's try another example. Determine the apparent power in kVA for a 150 ampere 120/240 volt single phase electrical system. Well, we know the amps, which is 150. So we'll punch in 150. And then you're going to go with your highest voltage, which is 240. So you multiply that times 240. That gives you 36,000. Then you're going to take that and you're going to divide it by 1,000. Remember, 1 kVA equals 1,000 volt amps. So we got the volt amps. You divide it by 1,000. That gives you 36 VA. Is there a 36 VA there? Yes, there is. And what is the answer? 36 VA. There we go again to get the kVA. Kilovolt amps. It's I, in other words, the amperage, the intensity, times the voltage. E, EMF, electromotive force. You multiply that, and then you divide it by 1,000, which is 150 amps, times the 240 volts, divided by 1,000. What does it give you? 36 VA. Now, let's say you have a three-phase system. Formulas used to determine the available power for three-phase circuits, loads, or electrical systems are. So it's basically the same, but then you multiply it times 1.732. And anytime it's a three-phase system, for voltage drop or other calculations, you will always use this number, 1.732. Got it? So, an example, determine the available power in volt amps for 100 ampere, 208Y, 120 volt, three-phase circuit. Very easy. You take the amperage, which is 100. You multiply that times the 208. That gives you 2080 times the 1.732 equals 36,025.6. Okay, is that available there? 36,026. Let's go with B. And there it is. Very easy. That's your available power in volt amps in that type of system or that circuit. And it's a three-phase circuit. Okay, let's do another example. A load that draws 50 amperes when connected to a 208 120 volt three-phase source has a kilowatt rating of? Very easy. You take the 50 amps, you multiply it times 208 equals 10,400. You multiply the 10,400 times 1.732 equals 1802.8. And then to get the kilowatt, what do? Well, you divide it by 1,000. Gives you 18.01. Is there an 18 there? There's an 18, there's a 1.8. What do you think? Well, we got 18. Let's see if it's correct. 18. And there you go. Current time volts times 1.732 divided by 1,000 will give you your kilowatts. How did you do? Well, today we focused on finding the power, which can be expressed in, as we mentioned, watts, kilowatts, etc., horsepower, kVA, stuff like that. Next week, we're going to focus on how to find I, which is your amperage. And amperage, or the I, can be expressed in amps, amperes, full load amps, stuff like that. We're going to discuss that next week. So practice that formula. Just get different numbers. Just practice, and that way, that formula of finding the power, aka watts, kVA, etc., it's on your mind. P over IE, pi. P equals power, I equals the intensity or the current, and the E, EMF, electromotive force, represents the voltage. I hope you enjoyed this.